Hey everyone. So in this quick video, I'm going to give you a brief tour of how to use the night sky planisphere. I'm going to try and hit some things that the video I linked in the assignment page might not have covered. Feel free to pause this video at any time to try and recreate these things or locate these pieces of information yourself. Okay, so let's start by seeing that this in white is the entire sky that's above the horizon. It's not a circle. It's because it's kind of trying to project a three-dimensional surface on a 2D surface, and that's hard, so it's not a circle. But everywhere in blue, right here, and then up over here, is the horizon. Okay, so this is the northern horizon, the eastern horizon, the western horizon, and up here is kind of the southern horizon, but really that's what the back is for. And so that's why you see south here. So the back, all of this, is the sky that's very, very close to the southern horizon. Okay, it's still above the horizon. Okay, so these stars here are still visible. Okay, so let's focus for right now on this side. Okay, so that's the horizon. Let's see. This central grommet point about which the sky rotates, that's the North Celestial Pole, right? You'll notice it's in the constellation Ursa Minor, and it's actually the star Polaris, right? Polaris is right there, but of course it's blocked because it's very close to that North Celestial Pole. And it's right there because that's the point in the sky that the sky appears to rotate about, right? It's the point directly above Earth's axis. So that point is right there. Let's see. The zenith, right? The point directly overhead for an observer is the point directly in the middle of the entire sky. So that's about in between north and south. So that's halfway about there. And the point in between west and east. So that halfway is about there. So trying to find the middle right there. That's the zenith location. Not the same as the North Celestial Pole. Okay. So the zenith is actually on the meridian line. Remember, the meridian splits the sky into east and west. So the eastern half and then the western half over here. The meridian exactly runs through the North Celestial Pole and the zenith. So that's the straight line there, okay? Whenever a star crosses the meridian, it will be highest in the sky, okay? So, for instance, let's find a star. That star Enif, right there, that star Enif is crossing the meridian line, okay, right now. All right. So those are a couple of locations that won't change depending upon the time and date. Next, let's look at how to find the position at a specific time and date. Okay, so let's say, well, right now is about noon on August 30th. So that's 12 midnight. 12 noon is on the direct other side of the sky. That little white triangle right there, that's noon. And so let's rotate the sky until that gray or white triangle points to August 30th. Right there. So now we've lined up the date and time, okay? And this is what the sky would look like. This is what's in the sky right now, okay? This is also exactly what's in the sky on, for example, February 13th at 1 a.m. Right there, okay? This is exactly what's in the sky, okay? It's also exactly what's in the sky at, well, 9 p.m. on April 15th, okay? This shows the sky and what's visible, okay? So that's how you align up the date and time. Just align up those two pieces of information. Let's see, a couple things about the sky itself. Notice these spokes right here, right? Those spokes. They are emanating from the north celestial pole, and they're going down and crossing the equator, right? That's the celestial equator, and that's the solid line right there. Okay, those spokes are measuring, let me turn this over so you can see it. Those are, those are measuring degrees of the declination. So notice equator doesn't have it, but that's 0. That little tick mark right there is plus 10, plus 20, plus 30, plus 40, 50, 60, they couldn't write it, 70, 80, and 90 is the north celestial pole. Right? That's the lines of declination, right? In other words, how close or how far away a star is from the equator, right? The celestial equator. Now going around the equator, we should see numbers in hours. So that's 12 hours, 11 hours, 10 hours, 9 hours. And notice as we go around, we see different hour markings. Okay, that's measuring the right ascension. So let's actually go around to, there it is, the vernal equinox, right there. 0 hours at 0 degrees declination. And that's the point in the sky defined as where the ecliptic, the dotted line, is crossing the celestial equator from the southern to the northern hemisphere, right? And we know this is the southern sky because the declination has a negative value. In other words, it's below the equator, or it's to the south, okay? And so remember, the ecliptic is the line that the sun takes in the sky throughout the year. The day too, but the year as well. And so the constellations that cross that dotted line, Pisces, Aries, Taurus, Gemini, those are constellations of the zodiac, okay? So I kind of digressed a little bit, but that's the vernal equinox. 0 hours right ascension and 0 hours declination, okay? And directly opposite, so following that over here, we have the autumnal equinox, 12 hours right ascension, okay? And so now the sun is getting lower and lower in the sky. It's going from in the northern hemisphere and crossing into the southern hemisphere, right? Just like the sun does in the sky. It's getting lower in the sky in the wintertime. Let's see. You'll need to look carefully, right, at the hours and the degrees. So pay attention to the negative or positive degree values. Some questions you'll need to estimate right ascensions. For example, halfway in between 11 and 10, right there, that's about, 10 hours, 30 minutes, 10:30. So for a couple questions, you'll need to kind of estimate, right? Oh, I should define this giant smudge, right? What do you think that is? If you said the Milky Way galaxy, you'd be correct, okay? So that kind of shows about where our galaxy is. You can also see these things on the back, right? The very far southern sky, okay? And if you notice, where am I? What am I doing here? Let's go to 20. Nope. I need to go over to, here it is. Sorry. Right there, this line here, right there, 18 hours right ascension, that ecliptic line is closest, right? It's just that far away from the south celestial pole, right? And that is in winter. The sun is in Sagittarius, right? It's the lowest in the sky it'll ever be, as an example. And so some questions may have you estimate how far from the southern horizon that is. So use those tick marks, right? That increment or that distance is 10. That's another 10. I need a more specific pointer, I'm sorry. So 10, 20, and then some, and then some. So use those tick marks to estimate degrees in that case, okay? That's just one of the examples that came to mind. Let's see. The brightest stars are the biggest dots, right? So Vega is an example. Altair is another example of a very bright star. The constellation names, by the way, are in all caps. Asterisms are in parentheses. And then, well, star names are in regular font. And I believe that's about it. Some questions will have you get creative, right? Or maybe a little tricky, asking, say, when a star is crossing the meridian on a certain day. Well, for example, Altair is crossing the meridian line, that line right there, right? That will not change, by the way. So between that point and that point, it's crossing the meridian. It's 12 noon on, well, it's crossing the meridian at 12 noon on January, what is that, 16th, okay? But also know that Altair is crossing the meridian at 2 a.m., for example, on June 18th, right? June 18th right there. And then Altair is crossing the meridian, right? Another example, Altair crosses the meridian at 9 p.m. on September 2nd, as another example, okay? When you're moving this star map, keep in mind that the sky sets in the west and rises in the east. That'll be important for at least one question I know offhand, right? Rises in the east and sets in the west. So like this, okay? And I think that's it, right? Oh, altitude and azimuth, right? So I mentioned right ascension and declination. Those are these spokes, right? The dashes there, and then the hour markings around the sky. Altitude and azimuth are simply measured from the horizon, right? So any star on this edge on the horizon is 0 degrees altitude. It's literally on the horizon, right? So for example, that bright star, Vega, is on the horizon, right there. And it's on the horizon, for example, at 10 p.m. on November 29th. Okay? Azimuth is measuring how far around the sky. So that starts at due north at 0 degrees. And then it goes eastward. Due east over here is at plus 90, right? It's a right angle. So 90 degrees. And then due south over here is 180 degrees. Due south, in other words, is this way, right? Down there. And going towards the west is 270, and then 90 degrees more back to where we started, okay, at 0. So that's altitude and azimuth. Remember, 90 degrees altitude is straight overhead at the zenith, right here, right? Not at the pole. The zenith is here. So this is 90 degrees altitude, and you'll just need to estimate that, right? And then azimuth is how far around, okay? So I hope this video has been helpful. Remember, this lab is due, let's see, Sunday, tonight, August 30th, right, by 11:59, okay? So I hope this video has helped you. Thanks for watching.